Hi, I'm Dan, and I'm in Year 11 at Priestlands, taking my GCSEs and applying to colleges, hoping to go on to study computer science at university. And I've recently created an application note on silicon chip design for teenagers. For this, I have demonstrated use of Verilog. Verilog is a HDL. No, that's not a courier service. Instead, it's a hardware descriptive language, allowing anyone to program an FPGA. In my mind, it's a code your own circuit board, allowing anyone to program its code your own circuit board from wires to logic. It is reprogrammable and therefore allows lots of different prototypes all mucking around. However, FPGAs are seen as a subject for university computer scientists. It is my belief that it can be adapted in such a way to make them suitable for schools to use in teaching. I used Quartus, a tool for converting FPGA bitstream, Verilog to an FPGA bitstream, a program that FPGAs understand, specific for Altera's FPGAs. However, the tools are not nice to use, not too painful, but they are nowhere near intuitive. It's really not designed for a learner like myself, although I could eventually find everything. On the other hand, in hindsight, I can see that maybe the use of a GUI is another step in the wrong direction. Why should we be learning to use these when inevitably you don't actually use this in the real world? But how did I learn this? How did some 15-year-old kid comprehend what is seen as a university subject? I learned a lot from the second chip hack in Cambridge, but I also understood some information from some university teaching materials, such as David Greaves' Learner's Subset, as well as the Chip Hack Wiki, and more importantly, some brilliant helpers. This shows that a teenager can, with some help, understand and digest the information if you direct them to the right place. Another important fact is that I needed to learn the very basics of computer logic, and this cannot be learned from starting at code. But there are some brilliant ways out there to learn this. For example, Minecraft. Minecraft can illustrate simple computer logic to the beginner, but can also create other stuff such as flashing lights or a fully functioning calculator. Computing doesn't have to be that boring subject it is so frequently stereotyped as. It can be made into something interesting and engaging. A key instrument of my success was the internet. This being the 21st century, you would expect this to be the norm whilst learning. However, as demonstrated by my beautifully drawn diagram, we don't use it enough in schools. We are supposed to rely on a teacher and their skills when we have a huge web of resources already in reach. I don't see why we should have to reinvent the wheel. Why shouldn't we be taught to find an already existing idea or solution? Outside of school, every job I have worked at, my first port of call is the internet. Surely a brilliant skill at school would be to teach us search optimization. How can we effectively find the results to our problems? Another huge difference from school is self-learning. I had time to tinker with what I had, therefore cementing how stuff worked. I was allowed to play around and change what I had. I wasn't constantly pressed for a result. I had stuff I knew and stuff I wanted to do, and frequently they crossed and I could manage to make it. But how could this possibly work at a school? Well, I believe it's similar to my German lessons at school. The common saying by the teacher is nick and adapt. This can be applied to code. I was shown code and had sources of it, which I could take and change the purpose of. I could take someone's simple program, making a single light show up, and make it display a binary number, someone's counter, into a Fibonacci counter. Another key idea I learned was a state machine. I first tried to make a lock, but failed before being introduced to a state machine. I was then shown what on earth a state machine was. I then thought and drew out how it would work. As you can see, my diagram helped me create a successful lock, allowing me to keep a binary number vaguely safe. But what do others think of my wizardry? Well, quite frankly, all the people I've told don't have any opinion. But then they're the people I've told. So there might be different opinions out there. Also, I asked people what they thought of a computer science so I could get a decent response for this slide. And I got an amazing reply. I don't even know what one is. How do we all use the internet several times a day and not know who/what invented it? Does this show that even the concept of computing is not even recognized at schools? Surely we should know these very basics. To the future. I'd like to finish this talk, and a possible game of OpenTTD later. But seriously, I would love to start a computing club at school. to create robots and other general geekiness from wire and solder. And in the not so far future, further future, I would love to go on to university, studying computer science, and then obviously become the next Elon Musk, become Bill Gates, and pretty much rule the entire world, and Mars. But a single step at a time. Finish this talk with my life. And that's the application note I'd made over the summer.
Thank you, Dan. I think there's actually an example. The lock program is running there. I think following a rather tense period on the train on the way up when we couldn't find the right cable. But just to prove.
I enter my code, which is 3, 4, 3, 7, and it will display my secret number in binary.